Solutions for the mock on quadratics. So first of all, they give us this drawing, and then they give us this quadratic equation, and they want us to identify the coordinates for A, B, and C. But they don't tell us the x coordinates or the y coordinates for A, B, and C. We're just supposed to get them by looking at what characteristic part of the quadratic they're on. And so obviously B is the vertex, and obviously C and A are x-intercepts. Okay. And actually the form that they give you, remember there's three forms. There's standard form, there is factored form, which is this one, and there's vertex form, which is the HK form. Since it's in the factored form, what does factored form automatically give you just from looking at it? It gives you the x-intercepts. And the way it gives you the x-intercepts is, if you write factored form, and you set it equal to 0, then you know that since it's two things multiplied together, in order to get 0, one of the two factors needs to be 0. So if I want to find the x-intercepts using factored form, it's pretty easy, because first I would say, okay, either the first factor, 7 minus x, has to be 0, or 1 plus x has to be 0. And probably not both, right? Both probably can't happen at the same time, but it doesn't matter. If one is 0 and the other is not 0, multiplying them together, you get 0, right? So let's do algebra and figure out, adding x to both sides, we figure out that this side, the solution is x equals 7. For this one, if we subtract 1 from both sides, we get that x equals negative 1. So the two possible x values which make the quadratic 0 are x equals 7 and x equals negative 1. So those must correspond to the two x-intercepts. So obviously C would be the positive 7 x coordinate, and obviously the y coordinate would be 0 because it's an x-intercept, so the y coordinate is 0. And then B, or A, would be the x coordinate of negative 1 and y coordinate of 0. Why is the y coordinate 0? Again, it's an x-intercept, so the y coordinate has to be 0. Now let's look at the vertex. How do we find the vertex? So one of the ways you could find the vertex would be to multiply this out into standard form, and then do negative b over 2a to find the x coordinate of the vertex, and then take that value and plug it into the equation to find the y coordinate of the vertex. But actually you could do something much more clever, and I'm going to show you this method because sometimes this is the only method you can use to solve this problem. Okay, sometimes they just don't give you an equation, and they'll say, oh look, this x-intercept is negative 1, this x-intercept is 7, what is the axis of symmetry, for example? And the way you can do that is, you could say, oh, well, I know this x-intercept, I know this x-intercept, and I know that the vertex has to be exactly in the middle of these two x-intercepts, so I'm going to count in a certain number of units to see where that middle would be. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to count in from 7, 1. I'm going to count in from negative 1, 1, 2, 2, 3, 3, 4, 4. So this is my axis of symmetry, and if I count 4 units in from 7, that means that this is 3. So my axis of symmetry is x equals 3. Remember, whenever you write an axis of symmetry, you do need to write x equals also, because the axis of symmetry is a line, and the equation of a line is x equals 3, not just 3. So the vertex, which is point B, I could write that it's 3 comma something. 3 comma what? Well, to get the y coordinate, in this particular case, I have a formula, or I have an equation, so I could just fill in 3. So 7 minus 3 times 1 plus 3 is equal to 4 times 4, which is equal to 16. So the y coordinate of the vertex is 3 comma 16. So those are my 3 points, negative 1, 0, 3, 16, and 7, 0. Moving on. This is a drawing again, and basically the only thing this drawing tells us is the vertex is on the x-axis and the parabola opens down. What does that tell you? Well, if we're considering the standard form of ax squared plus bx plus c, we know that a would be negative in this case because it's opening down, right? Just from the drawing, we can tell that a is negative. What about the value for c? Do we know something about the value for c? Well, remember, one of the only useful things that standard form tells you, besides the a value telling whether the thing opens up or down, but that's not that great because the other two forms also have the same a value. One of the only useful things that standard form tells you is the c value happens to be the y-intercept of the function. So I see that the y-intercept is here. So this looks like, from the drawing, the y-intercept is negative because it opens down. So actually my c value is also negative, isn't it? And the last thing we can tell from the drawing is that we do have the vertex to the right of the y-axis, which means that the axis of symmetry, negative b over 2a, is greater than 0, right? So those are the three pieces of information we can figure out. Now we're going to try to fill in this table here. They're asking us, what do we know about the a value? What do we know about the c value? What do we know about b squared minus 4ac? What do we know about b? So we already know that a is negative, right? So I'm going to put here that a is negative. We already know that c is negative, so I'm going to put here that c is negative. And then it asks us, what is b squared minus 4ac? And remember, b squared minus 4ac is the discriminant. In this particular case, how many x-intercepts we have? We have one x-intercept, which means that the discriminant is 0, right? Because the way you figure out x-intercepts is you use the quadratic formula. And if you have exactly one x-intercept, that means that this part of the quadratic formula, the square root with the discriminant inside of it, is 0, and that's why there's only one x-intercept instead of 2, because when this part is not 0, when it's a positive number inside the square root, then you're going to generate two different x-intercepts, and then you get a quadratic which crosses twice the x-axis. So in this particular case, since it crosses once, we know that the discriminant is 0. Okay, now the last thing. If we know that negative 2b over 2a is greater than 0, and we know that a is negative, that means that b would have to be positive in this case, right? Because if b is positive, do you see how this is a negative number because a we know is negative, and this negative cancel out, and then we're left with b over 2 is greater than 0. If b over 2 is greater than 0, that means b has to be greater than 0. Okay? So that was probably the most difficult thing. b is greater than 0. So b is positive. All right. Moving on to number 3. Consider this terrible-looking equation when k is not equal to 0. The equation set equal to 0 has two equal roots. This is just another way of saying two x-intercepts, it says two equal roots, not two distinct roots. So that means actually the same case as we just saw here, where the parabola touches exactly the x-axis, and there's only one x-intercept, okay? Two equal roots means there is one x-intercept. So if there's one x-intercept, that's code for the discriminant is equal to 0, right? So we do know that this discriminant, which is b squared minus 4ac, as we can copy off out of the formula sheet, and then in this case, a is 2k, right? B is negative 4k, and c is positive 1. So why don't we fill those in? So we'll say a is equal to 2k. It's not 2kx squared, right? Because the form is ax squared plus bx plus c, right? So 2k is a, minus 4k is b, not 4kx, 4k, right? X is separate. And c is equal to 1. Now let's put those numbers into the discriminant and see what we're going to do with that. So negative 4k, whenever you substitute into b with squared, you need to put parentheses around negative 4k, minus 4 times 2k times c, which is 1. Now let's simplify this. Now we can see the reason why we needed to put parentheses around here. If we have negative 4k quantity squared, that's the same thing as negative 4k times negative 4k, which means it's positive 16k squared. 16k squared. Minus, and then we have 4 times 2, which is 8k. So we want this to be equal to 0. So let's factor out a k now, and we'll get 16k. Oh, we can factor out more than just a k. We could factor out a 8k, right? That's a common factor of 8k. If I factor out 8k, I end up with 2k minus 1 equals 0. Why am I factoring? Because I'm trying to figure out all the solutions for k, and in order to do that, I need to factor to see every possible solution. Somebody might say, oh, there's a 0 on one side, so I'm going to divide both sides by k so I can get rid of one of the k's. But if you do that, you're going to lose the solution k equals 0. So instead of blindly dividing out variables and losing them, factor. Okay. So here we have ak times 2k minus 1. And in this case, what are the values of k which can make this expression equal to 0? Well, 8k might be 0, and 2k minus 1 might be 0. Those are the two ways that this whole expression would become 0. So ak equals 0, k is equal to 0. If I divide both sides by 8, I found out that k is actually equal to 0. The other possibility is 2k minus 1 equals 0. If I add 1 to both sides, I get 2k equals 1. And if I divide by 2 both sides, I get k equals 1/2. So the two possibilities are k equals 0 and k equals 1/2. But they already told us, they already told us that k is not equal to 0. So this is actually, we already know it's not true. So we're left with k is equal to 1/2. That is the only solution. That is the only value of k which makes it true. Now, if you were looking for discriminant is greater than 0, or if you're looking for discriminant is less than 0, this would be the first step. Find when k is equal, k makes the discriminant equal to 0. Then you would need to make your number line and do a sign diagram, marking first that k equals 1/2 and k equals 0. Make the expression 0, and then you test points in between to see when the thing is positive or when the thing is negative. Okay? But in this particular case, we don't need to do that because we're just looking for discriminant equals 0. It's slightly easier. Okay. Then we go down. So in this particular case, we already know that when k equals 1/2, we know that this equation here has 2 equal roots, right? Section B asks us, if you have a line y equals some number intersecting the graph, find all possible values of the sum number that would make the intersection work. Now, if k equals 1/2, I'm just going to see what exactly does this function look like in the end then. It's f of x equals 2 times 1/2. I plugged in k equals 1/2 there. X squared minus 4 times 1/2 times x plus 1. 2 times 1/2 is 1, so x squared minus 4 over 2 is 2, 2x plus 1. So here I have a parabola which opens up, right? Because a is positive 1. So I'm going to make a drawing here. If I have this parabola, and it's off center. It's not going to be like exactly on there, but it doesn't matter. The important thing is that it touches the x-axis once. And then I have this line y equals p. Do you see how the line y equals p is a horizontal line? And it's at height p. So they're saying, when does this line y equals p intersect the red parabola? Well, it pretty much intersects at any time unless we happen to draw it down here where there's no parabola. So where is the point which is the difference between y equals p intersecting the red parabola and where it doesn't intersect the red parabola? Right here. Height y equals 0. At height y equals 0, there is the vertex. So if we make y equals 0, then it intersects, right? If we have y is less than 0, do you see how it does not intersect anymore? Okay, so does not. So they want all possible values of p where it does intersect, so that leaves y is greater than or equal to 0. Okay? Moving on to the next one. They give us a parabola or quadratic in standard form. Then they tell us to put it into this form, which is known as vertex form, right? Remembering that it is vertex form, the first step to finding vertex form is to find the vertex. And what's the easiest way of finding vertex? Using the axis of symmetry equation and then putting that value into the original equation to find y. Another possibility is to do complete the square, but I just told you before that only work with complete the square if you are totally comfortable with it today. Otherwise, it's one more thing to learn for the 50th time, right? So here, for B, I'm going to put negative 12. For A, I'm going to put 2. And for C, I'm going to put 5. So B is negative 12, so minus negative 12, because there's a minus here too, right? And then I'm going to put that over 2 times 2, because the A value is 2. So basically that's positive 12 divided by 4, which is equal to 3. So the x-coordinate of the vertex is equal to 3. How do I find the y-coordinate of the vertex? I simply put 3 into the original f value, or the f function. So that would be 2 times 3 squared minus 12 times 3 plus 12, which is equal to 2 times 9, which is 18, minus 12 times 3, which is 36, plus 12. So that's equal to 12 plus 18 is 30, minus 36 is minus 6, negative 6. So the vertex is equal to 3 comma negative 6. Now I can finally write this equation. It's y equals 2 times x minus 3, because h is 3 and k is negative 6, so I put minus 6. Make sure you put the squared there. Okay? So that seems like a lot of work to do A, which is only worth 3 points, but now that we have that, look, B, they ask, write down the vertex of the graph. Now that we've put it in that form, we know that the vertex is 3, negative 6, or we found the vertex like we did just to put it in that form. But so maybe this problem would have been easier if they would have done this in the opposite order. Maybe if they would have done C first, that would have been easy, because look what they ask you. They ask you for the axis of symmetry. The axis of symmetry, we already figured it out. It's up here. The x-coordinate of the vertex is the value we use for the axis of symmetry. Now, do not write just 3, because axis of symmetry is a line. This dotted line here is the axis of symmetry. A line has to have an equation, not just a number. So in this case, the axis of symmetry is x equals 3, because it's a vertical line, and vertical lines have x equals a number. Find the y-intercept of the graph of f. Okay, so there is probably the easiest way to do that is to look at the original equation, which is in standard form. Remember, one of the only useful things that standard form tells you is the c value, which also happens to be the y-intercept, so I already know that the y-intercept is 5. If you don't remember that, remember that the y-intercept has an x-coordinate of 0. So if you know that the x value is 0, you could either put 0 into this equation or put 0 into this equation and do the arithmetic and find out that the y-intercept is 5. So you could put 0, 5, or you could just put 5 because y-intercept is a number. Last part. The x-intercepts of the function can be written in this form, and that looks really familiar. It looks kind of like a quadratic formula, so that's a hint. You should use quadratic formula, where p, q, and r are, and big Z means integers or whole numbers, positive or negative whole numbers. Find the values of p, q, and of r. So in this case, basically we're looking for the x-intercepts of this quadratic equation. Remember, A is equal to 2, B is equal to negative 12, and C is equal to 5. Let's plug those into the quadratic formula. Remember, quadratic formula, if you don't have it completely memorized, go ahead and copy it out of the formula sheet, because that's like a really dumb way to lose points, to like write down quadratic formula wrong. Okay, so negative 12 plus or minus square root b squared. Now b squared, we would write it like this: negative 12 in parentheses squared minus 4 times a, which is 2, times c, which is 5, divided by 2 times a, which is 2 times 2. What's the difference between writing negative 12 squared and negative 12 squared? This is equal to negative 12 times negative 12, which is equal to positive 144. Negative 12 squared is actually equal to negative 12 squared, which is equal to negative, and then inside the parentheses, 144, so it's equal to negative 144. So technically, if you write this, you are writing an incorrect expression, which could lead to points off. Okay? So don't do that. Put parentheses around things. When you substitute in for a variable, one of these letters, put parentheses around it. So for negative b, the correct thing to do would be to put negative and then negative 12. It's just that I put 2 negatives there because for students, I think it's easier for them to see that the two things cancel each other out. But, you know, there's no confusion there, right? All right. So negative 12 is positive 12. Inside the parentheses, I have negative 12 times negative 12, which is 144, minus 4 times 2 times 8, which is 40. So I have plus or minus the square root of 144 minus 40 divided by 4. So 12 plus or minus the square root, and 144 minus 40 is 104, divided by 4. So my p value is 12, my r value is 4, and my q value is 104, because I just looked at this formula here, and I compared it to what I have here, and I figured out what each letter was. Okay? And that's it. I think that's the last problem in the exam.